Alright, now, so then the model here is of the 1/8 octahedra with the two sizes, 5 scales down, 1/8 octahedra, and for purpose of scale comparison, in E-module form. The reason I say E-module form is its dimensions are not going to be the same as an E-module. And the fundamental difference is that it's actually a function of a second root of 2 involved. So what I was going to say is that the E-module form, where this edge here is typically 1 from here to here, it's now going to be proper scale, it's going to be second root of 2, square root of 2 times phi to the negative 1. I guess we could pop that up real quick on our Google screen and get that edge length. So it's going to be square root of 2 times phi and it's supposed to give us an answer, but I think I put the capital and the phone was ringing. And anyway, it's not working. It used to work for me. No, it's not. So instead of 1, the edge is going to be 0.874032, which is second root of 2 times phi to the negative 1. Now, since we have done that, the volume change is going to be to the third power, and we will get an answer 0.667701. So this can also be written as 2 times square root 2 times phi to the negative 3 there's your 0.667701. Okay, so now that's the amount we're changing the E module to. So the E module, once again, was square root 2 over 8 times phi to the negative 3 itself. And then we get this number 0.027864, which is phi to the negative 6 over 2. Let's see now, do we want to go back to my visual? Okay, so now we've sized this E-module form so it's the same as this 1/8 octahedra. Remember, they had a volume like 0.027. Now, what we've also been doing here is to create the actual S module, we phi increase one edge, and then we connect these dots, lines. Oh, clicked the wrong one. Didn't look right. Okay, right here. And that generates another tetrahedron that's attached to that 1/8 octahedra that's 2 sizes down. And this volume here is actually phi to the negative 7 over 2, this tetrahedron. But if you add phi to the negative 7 over 2 plus phi to the negative 6 over 2, you have phi to the negative 5 over 2. So what we're saying is that the overall volume of the S module is phi to the negative 5 over 2, which is phi to the negative 6 over 2 times phi. Okay, so that is what I'm trying to show is what the relationship is between the E module form and the S module, and this is the best I can figure. So if we go back to this here, the calculating, you may recall that the factor that I was multiplying by the S, this is the, okay, first of all, I'll highlight the S module. Pardon me, this is the E module volume. And then I've calculated, then I've used this factor here to bring it to that size, so to speak, that's the same as the one octahedra. Now, if you're familiar with the S module or the S factor, it's really just -2 instead of -3 here. It just changes the amount. So that gives you your S module volume. So by, it affects stepping up one spot after we've already knocked the E module into the right spot, then we step it up one spot from a -3 to -2, then we get our S module volume. That's what I'm trying to say, and I hope it makes some sense somewhere. But that's how I see the relationship between E and the S module and the S factor.